So here's number 2 from the AP packet. Let's read it. The salmon population on an island is modeled by a differentiable function p of time t, where p of t is the number of salmon and t is measured in years. There are 100,000 salmon on the island at t equals 0. The birth rate for the salmon on the island is modeled by b of t, and the death rate is modeled by d of t. And they're both in salmon per year. What is the rate of change of the salmon population on the island at t equals 0? So rate of change of the salmon population, where p is the population, so p of 0 would give me the population at time 0. Since I want the rate of change, I want p prime of 0. Since I'm looking for the rate of change of the salmon population, they gave me two functions, one that represents birth and one that represents death. So the population can be easily modeled by b of 0 minus d of 0. This represents the birth rate at time t equals 0. This represents the death rate at time t equals 0. And then when I subtract them, that gives me the population rate, or the rate of change of the population. I can do this by hand. 0.06 times 0 minus 250 e to the 0.1 times 0. This gives me 1,000 minus 250, which is 750. I can also just skip from here to 750 because I'm allowed to use a calculator on this question. And this would be 750 salmon per year, even though it doesn't ask for units. For part B, to the nearest whole number, what is the salmon population on the island at t equals 40? Well, if I want the salmon population, I actually want p of 40. But b and d are rates. So what I need to do is I need to integrate that rate to go from salmon per year, because that's what it says right here, salmon per year, to just salmon. Now, when I integrate from 0 to 40, one thing you have to be careful about is don't put b of 40. It's very common for a lot of people. You're still integrating a function and you're as a curve. So if the graph looks like this, I'm looking at the function between b and d. If I plug in 40, I now have a constant, and you'll be integrating the area underneath this constant, which doesn't make much sense. Now this, to put into terms, only really tells me the displacement, or the change in population. So what do I need to do? I need to add how many salmon were in the lake at the very, very beginning, which was p of 0. So if you remember, this and this term should always match up. Put it all in the calculator, and you get 133057.564. And since it says round to the nearest full number, the answer should be 133058 salmon. C, to the nearest whole number, what is the average rate of change of the salmon population for the island from 0 to 40? There's two ways you can do this. You can think about the average rate of change as your slope. Or you can think about the average rate of change as the average value of the rate. If I want to make it a slope, that's probably the easiest, and that'll just be p of 40 minus p of 0 over 40 minus 0. P of 40 I found earlier, so that's 133058 minus 10000 over 40, which comes out to be 826 salmon per year. If I instead want to think about it as average value of the rate, I would need to do 1 over b minus a, so 40 minus 0, times the integral from 0 to 40 of b of t minus d of t dt, since these represent my rate. I put that in the calculator, I also get 826 salmon per year. You're only allowed to do one way on this problem, but whichever way you choose, as long as you show your work and have the answer, you should have all the points. Now the last one. To the nearest whole number, find the absolute minimum salmon population and the absolute maximum salmon population on the island from 0 to 40. Show the analysis that leads to your conclusion. All of it. So, immediately, absolute minimum, absolute maximum, that should register that you will need a table. Now, a table of what? Well, the independent variable is t. That's pretty clear. But since I'm trying to maximize and minimize the population, this will be p of t. So, what goes in the table? Well, as always, I need my critical points, and I need my endpoints. My endpoints, already given, 0 and 40. And in fact, I already know the population at 0, it's 100,000, and the population of 40 was what I found in part B, 133,058. Critical points. Back to basics. Critical points of P of t is when P prime of t equals 0. Well, earlier, I was able to see what P prime was. P prime equals B minus D. So that means B of t minus D of t equals 0. Because this is a calculator question, you can come up with the value of t, but you need to show the AP reader where you're getting this number from. It is not acceptable to say, I used the graph, I found intersections on my graph. I had to formulate some equation that algebraically can prove where I got t from. And therefore, if I plug this into y1 and plug this into y2, or I use a solver, I will get that t equals 34.657. Do not round this number. Store it. Store it into A. In order to actually find P of this number, I will have to do what I did earlier in part B to find the population. It'll be 100,000 plus the integral from 0 to A of B of t minus D of t dt. Calculator says population is 139,166.667. So 139,166. If I round to the nearest salmon, it'll be 139,167. Okay. Answer these types of questions in a sense. All the analysis is right here. It's clear to me what I was doing. I have my critical points, I have my endpoints, and I should also have the value of A right here. So write a sentence to finish my thoughts. My thoughts will say something like this. The absolute minimum population of salmon is 100,000, because that's what they're wanting. They want the population itself. At t equals 0. The absolute maximum population of salmon is, well, looking at this table, I can see where the absolute maximum occurs. It's 139,167 at t equals 34.657 not days, years. I should write years here too. That's it. If you want to know how the point spread worked on this one, this question was worth 4 points. 2 points fell in with these two parts. You can't use A without showing me where A came from. So if you chose to use A, if you didn't show me one of these two functions or something similar to that, you couldn't get up to 2 points. And then the rest of the work is where the other 2 points came, being able to find the minimum and being able to find the maximum. In this one, it was just 1 point, having your answer with some sort of work. Part B, this one was worth 3 points. This one's 2 points for having the integral set up correctly. It's 2 points right there. And then 1 point for having the answer. Now you won't have the answer point unless you use the initial value. And in part A, it was only 1 point. Again, showing me some sort of work, but it was really only 1 point for having the right answer.